Hello students, welcome you to this video. In this video we are going to study some of the very simple thing, minors, cofactors. So that's a very simple thing. Then after that, how to multiply two determinants. Then the relation between cofactor and the value of the determinant, everything we are going to study. Okay. So first we start with minors and cofactors. So minor, suppose A is a matrix 3 by 3. Minor, we denote it as minor of A1. A1 is the position, the first position, right? You know the position. The first one is A11, A12, A13, right? A21, A22, A23, A31, A32, and A33, right? So minor of the element in the first position, that we denote it as M11. So what you do now, leave that row, that column. Take the remaining determinant, take this part, write it as a determinant and simplify. That is the minor of A1, right? So determinant B2, B3, C2, C3. So minor of the first element, leave the row and column. So this one you simplify. Straight also you can do. You multiply these two, then multiply other two, right? So B2, C3, B2, C3 minus B2, B3, C2, right? So like this you can find the minor. So far, suppose you want to find the minor of this A3. That is in the position 1, 3. So M13 we denote. So that row and that column you leave it, right? So A3 is here. That particular row and that column you leave it. You have 4 numbers here. So now usual determinant multiplication. B1, C2, right? B1, C2 minus B2, C1. Suppose you want to find the minor of say this number B3, that is in which position? 2, 3, right? So M23, minor of the element which is in the position 2, 3. Leave that particular row, that particular column. 1, 2, 3, 4. These are the 4 numbers you have. Multiply this. A1, C2, A1, C2 minus A2, C1, right? A2, C1. So like this you can find minor of any element. Suppose, take one more. Suppose I want to find the minor of this number. Leave that particular row, that particular column. So these 4 elements you take A2, B3 minus A3, B2, right? So like this you can find minor. See, look at this one example. We consider this one. Suppose I want to find minor of minus 5. Minor of minus 5. See, minus 5 is here, right? Minus 5 is here. Leave that particular row, that particular column. So 1, minus 2, minus 3, 2. These are the 4 elements. If you want, you write here 1, minus 2, minus 3, 2 initially. But later no need, no? So just you multiply like this. 1 into 2. 2 minus 3 into minus 2. Minus and minus plus, so it won't affect this, right? So 2 minus 3 2s are 6, right? So your answer is minus 4. Suppose I want to find the minor of, say, 5. Minor of 5. Leave that particular row and that column you leave it, okay? So 1 into 6, 6, right? So minor of 5. So 1 into 6, 6. Minus, here 4 into minus 2, minus 8, minus, so plus 8, you are getting 14, okay? Suppose, instead of minus 5, if here also it is say, this is also minus 5 for example. Then if the question is find the minor of minus 5, you have a doubt which minus 5 we mean, right? So that is the reason normally the question will be find the minor of the element A32. A32 means, you know, third row, second column, right? So this one, A32. So we have to find the minor of that 5, okay? Okay, so that's all about minor. Then the next one we have to study cofactors. See, what is cofactor? Cofactor means it is signed minor. Cofactor means it is signed minor. Cofactor we use capital C or capital A. You can write it as Cij, cofactor. Minor Mij, right? Cofactor. Or you can write Aij, capital Aij. What's the formula, you know? You write Mij, but before that you write minus 1 raised to I plus j. Minus 1 raised to I plus j into Mij. So, please listen here. The cofactor means it is minor only. But before that we have something here, right? minus 1 raised to some power. Minus 1 raised to any number you give, you won't get your answer as 25 or 47. Minus 1 raised to any number, either your answer is minus 1 or your answer is plus 1. Depends on the power, right? If the power is even number, minus 1 raised to 2 or minus 1 raised to 4 or minus 1 raised to 200. If the power is even number, it is positive plus 1. If it is odd number, if the power is even number, the answer is plus 1, right? If the power is odd number, minus 1 raised to 1 or 3, 5 or 27 or 275. If the power is odd number, then your answer is what? Minus 1. So this minus 1 raised to I plus j decides the sign, whether it is positive or negative. After that you are going right, minor only, right? So that is why cofactor is what? Signed minor. We are going to write minor, but we look into the sign also. See how to check the sign. You know the position. Minus 1 raised to I plus j. Minus 1 raised to I plus j. That is the ij, aij or cij. Ij is the position, right? Which row, which column. If I take the first number, a1, I is 1, j is 1. So 1 plus 1, it is 2. It is 2. If it is 2, it is even number. So minus 1 raised to 2. So it is positive. Next number 1, 2. So 1 plus 2. I is 1, j is 2. 1 plus 2, 3. Odd number. So minus. 1 plus 3, 4. Even number plus. Then 2 plus 1, 3. So 3 means odd number. Minus. 2 plus 2, 4. Plus. Minus. Plus. Minus. Plus. First time you try to understand and learn. But when you go for the examination, just you put if it is 2, 3 by 3. If it is 3 by 3, the signed minor. The sign is plus, minus, plus, minus, plus, minus, like that. Alternatively, you write, then you write the minor, okay? So hope you understood that one. See this example. But that is for 3 by 3, I said. But if it is for 2 by 2, please listen. For 2 by 2, 2 by 2 means you know the position. A11, A12, A21, A22, right? So see the sign here. First one is 1 plus 1, 2. 2 is even number, so plus. 1 plus 2, 3, odd number, so you put minus. 2 plus 1, 3, odd number, again minus, then plus. Here, so here it is plus, minus, minus, plus. This is for 2 by 2. For 3 by 3, alternatively, positive, negative, like that you change, okay? Okay, now please listen here. Suppose I want to find A22. A22, that means I have to put plus or minus. 2 plus 2, 4, even number. So it is what? Plus. Actually, minus 1 raised to I plus j, 2 plus 2. This is how we are getting. 2 plus 2 is 4. 4 is even number. Minus 1 raised to 4, it is plus 1. Now you write the minor, right? 2, 2 means this number. They can ask find A22 or find the cofactor of minus 5. So it is positive only. Leave that row, that column. Now 1 into 2. 2 minus 3, minus 2. So totally 3 minus, so it is minus only. 3 2s are 6. So you are getting minus 4. Outside plus only, so your answer is minus 4. Suppose I want A32. A32. 3 plus 2, 5. Minus 1 raised to odd numbers, right? 5 is odd number, so it is negative. 3 2. See, 3 2 means which position? 3 2. 3 2. This number, right? This 5. 3 2. Leave the row. Leave the column. So 1 into 6, 6 minus 4 into minus 2, it is minus 8, so plus 8. So it is minus 14, right? Suppose I want A33. A33 we want to find. So it is positive or negative? It is positive, right? Because 3 plus 3 is 6. Even number, so it is positive. So 3 3 means which number is there? 3 3 means this 2. Third row, third column. Leave that particular row, that column. Now 1 into minus 5. Minus 5, minus 4 3s are 12, right? Minus 5, minus 12. Minus 5, minus 12. So it is minus 17. Outside plus only, so there is no change. Suppose outside is minus, then minus into minus 17, your answer is plus 17, okay? So hope you understood minor and cofactor. Okay, now some of the very important relations I want to teach you. Listen. A11, A12, A13, A21, A22, A2. So this is a matrix. A is a matrix given. The cofactor of the first element, A11, we denote it as capital A11. A12, the cofactor is A12. A13, the cofactor is capital A13. So every element, you know the cofactors. Now please listen. First row elements you take. you take first row element. What are the first row elements? A11, A12, A13. First row element. Take its cofactors. What are the cofactor? First one's cofactor is A11, second one's cofactor A12, third cofactor is A13. You multiply and add. So you multiply and add. So if you multiply and add, your answer is determinant A. If you write it as a determinant, what answer you get, that will be the answer here also. So what you need to understand here, one row element, multiply by its own cofactor and add it, your answer is value of the determinant. One row, multiply by its own cofactor. But now, first row element you take some other row's cofactor. For example, you take second row's cofactor. A21, cofactor is A21, A22, A23. What we are doing here, you are taking first row, you are not taking its cofactor, you are taking the cofactors of the second row or even the third row. Multiply and add, then your answer will be 0. That is the second result. A11 into A21. First element, but some other row's cofactor, right? A12 into A22, A13 into A23, then your answer is 0. What is the first result says? You take one row, multiply by its own cofactor and add it, your answer is value of the determinant. First row means its cofactors. Second row and second row's cofactor. Third row, third row's cofactor. Then your answer is delta or determinant A. But you take one row element, multiply by some other row's cofactor, then your answer will be 0. So two results. Hope you are thorough with that. And the third result, suppose a 3 by 3 determinant is given. A1, A2, A3, B1, B2, B3, C1, C2, C3. The value of the determinant is, say, determinant A, 25, something like that, right? Now, you find the cofactors of every element. A1's cofactor, capital A1, A2's cofactor, capital A2, etc. C3's cofactor, capital C3. You find the cofactor of every element, okay? And you are going to replace this determinant, replacing the elements of the determinant by the corresponding cofactors. Instead of A1, small a1, I am going to write capital A1. Instead of A2, capital A2, and so on. For every element, for all the 9 elements, we are replacing the elements by the corresponding cofactor. Then your answer will be, here answer is determinant A. In that case, your answer is determinant A the whole square. Suppose here the given the determinant value 25 means if you replace elements by the corresponding cofactors, then your answer is 25 square. Okay, but this is only for 3 by 3. It is only for 3 by 3. If you replace the elements by the corresponding cofactors, then your answer is determinant value the whole square. That is for 3 by 3. But for what about the other order determinants, 2 by 2 or 4 by 4? So I'll give the general result. Okay. So delta C equal to delta n minus 1. What's the meaning of this? This is the determinant replaced by the corresponding cofactors. Delta is a given determinant. The value is something 25 like that. Then the answer, when you replace the elements by the corresponding cofactor, then your answer is delta raised to n minus 1. Determinant value raised to n minus 1. That is why in particular if it is 3 by 3, delta C, the determinant replaced by the cofactors. Elements are replaced by the cofactor. Then your answer is delta raised to n minus 1. Here the order is 3. So 3 minus 1, 2. That is why we are getting determinant A the whole square. If it is 2 by 2, what happens? Delta C is equal to delta raised to 2 minus 1. 2 minus is 1 only, right? So if it is a 2 by 2, determinant value 25, replace elements by the cofactor, again no change, your answer is 25 itself. That is in the case of 2 by 2. 3 by 3 means delta square, determinant value square. Okay. 4 by 4, 4 minus 1, right? 3, delta cube or determinant A the whole cube. Okay. So don't take it as a result for all the determinants. It is only for 3 by 3. Okay. Now let us see how to multiply two determinants. All of you know how to multiply two matrices, right? Row by column. First row by first column, first row second column, first row third column, then come to the second row, right? That you studied in 10th standard. How to multiply two matrices. How to multiply two determinants. Listen, suppose two determinants are given. This is one determinant, this is another determinant. Very simple way. You simplify this determinant, one number you are getting. Simplify the second determinant, you are getting some answer. Then you multiply the two answers like that also you can do. Okay. Now, also you can multiply row by column method as we do for matrix, right? Row by column. That method you can use here. Row by row method you can use. Column by row you can use, column by column you can use. Any method you use. Don't simply multiply the corresponding elements. Okay. Row by column, row by row, first row into first row into second row into third row, then second row into first row, like that. That is called row by row. Any method you do, your answer is same because some of the important properties. When you interchange rows and columns, there is no change in the determinant, right? All these we studied. But normally we use this one. Whenever necessary, you can change the method. Okay, so any method you can multiply, and this one I said already, determinant AB can be written as determinant A into determinant B. So you can separate and do that. Determinant AB and determinant BA are equal, but you know in matrix, AB is not equal to BA in general. Matrix multiplication is not commutative. But when you write it as a determinant, determinant AB and determinant BA both are same. Okay, now using determinant you can find area of a triangle. Already in 10th standard you would have studied, right? Half into x1 into what formula is there. Using determinant also you can find the area of a triangle if the three vertices are given. The three vertices are x1, y1, x2, y2, x3, y3. Then area of the triangle is half into, write it as a determinant. First point is x1, y1. You write x1, y1. Second one is x2, y2. Third one is x3, y3, and the last column you write 1, 1, 1. Whatever answer you get, you write that much square units. Even if your answer is negative, you know area cannot be negative, so take it as what positive value. If the area of the triangle is 0, you know the points are collinear, right? Okay. Now, singular, non-singular, I think already I taught in some video. Singular, a matrix, it must be a square matrix. Only square matrix you can check whether it is singular or non-singular. You find the determinant value. If the determinant value is 0, you say the matrix is singular. If determinant value not equal to 0, you say the matrix is what? Non-singular. Okay. So that's all the concepts for the fourth exercise. So with this idea, you can do the sums. I'm going to teach you a few sums. Now, first one, show that this determinant and lot of letters there, right? Equal to ABC, BCA, CAB, the whole square. Please listen, students. For these type of questions, you start with LHS or RHS. Depends on where you have this square. You start with that. So here, right side, we have the determinant square. So I'm going to start with right side here. Okay. So I'm going to start with RHS. Okay. We are going to start with RHS. And you have to get LHS, right? You have to get LHS. And what is LHS here? ABC minus A square and so on, right? Okay. Now please listen here. We are starting with RHS. The whole square. So write it 2 times. ABC, BCA, CAB. Into, once again you write the same thing. ABC, BCA, CAB. Multiply and check. Some questions you will get the answer directly. Some of the sums in your book, one of the example sums, you do direct multiplication, row by column, you will get the answer directly. Some 2 marks, they can ask questions like that. So here if you multiply, first row, first column, please listen, A into A square. Yes, we want A square, but we want minus A square, right? Then B into B, B square, C square. But we don't want B square, C square, we want BC, right? So you have to make some change. So don't try to mug up, see the answer, what do you get? So please listen. Suppose if I interchange these two, that is I am writing C here and B here, what will happen, you know? A into A square. Okay, we want A square, but we want minus A square, we'll see later. Then B into C, BC, C into B, BC, B, CB means BC. BC plus BC, 2BC. Yes, 2BC we need. Only minus A square. You know, one of the properties says you can interchange 2 rows. If you interchange 2 rows, you have to put a sign minus. Okay, that minus you can adjust with the first row, so you will get the answer. Please listen very carefully. So what I am going to do, first determinant no change, ABC, BCA, CAB, right? First determinant. Second determinant, we are going to interchange second row and third row. So what step you can write? In the second determinant, we are interchanging R2 and R3. But the property says if you interchange 2 rows, you have to change the sign. So you put a -1 into. Please listen very carefully, you have to be very careful. So don't put simply a minus here. If I put a minus here, the meaning is you are subtracting two determinants. Okay, so you have to be very careful in writing this. So actually here multiplication, right? You are going to multiply. When you interchange 2 rows, you are getting a minus, and that minus you write like this. Okay. So first row no change, ABC. Second row, third row we are interchanging. So third row comes up CAB and the last one is BCA, right? Now by that -1 you multiply the first row. So ABC, BCA, CAB into, in a matrix, if you want to multiply by some number, you have to multiply all the elements, all the 9 elements. But in determinant, not like that. If you want to multiply by k, you multiply any one row or any one column. So here minus, I'm going to multiply with the first row because a square, we had a problem. We want minus a square. Now you'll get it, right? First row, you multiply by this minus. So minus a, minus b, minus c, remaining no change. C, A, B, B, C, A. That's all. Now straight away write the answer, you will get full mark. See, but you check it, okay? First row, first column, check. A into minus a square, yes. B into C, BC, C into B, BC, BC plus BC, 2BC. You check one more. First row, second column. A into minus B, minus AB. B into A plus AB. C into C, C square. If you want, you can write this step also, okay? Minus AB plus AB cancel, you are getting what? C square. Like that, you'll get everything. If you want to check the last one. Examination hall, no need to waste time. Third row, third column. C into minus C square. A into B plus AB. B into A, that also AB. So AB plus AB, 2AB, right? 2AB minus C square, yes. You are getting all the elements you will get. So see what we did here. Try to understand the method. You start with the square. Write it 2 times. Multiply and check. Some you may get the answer directly. If not, you see what change you have to take here. Here we interchange the 2 rows, right? In another sum, second row fully you multiply by minus, third row also multiply by minus. So 2 times you multiply minus, there is no change, right? Then when you multiply, you will get the answer. So it depends on the question. So no need to mug up anything, just see what answer you have to get, such a way make some change, okay? Now let's move on to the next question. Please listen. Show that the points are collinear. Don't use 10th standard method. Collinear means area of the triangle equal to 0, right? So this is our x1, y1, x2, y2, x3, y3, right? So area of triangle is equal to half into determinant x1, y1, x2, y2, x3, y3. Finally, you write last column, you write 1, 1, 1. Substitute the values, that is 1 by 2 into x1, y1, that is a, b plus c. B, C plus A. C, A plus B. The last column, 1, 1, 1. We have to get the answer as what? 0, right? So don't expand it. So very easy property, you can use it, right? B plus C, what is missing? A, but A is here. Just add it, okay? So what I'm going to do, 1 by 2 into, first column you write as it is. Second column is, second column plus first column. If I add these two, you will get A plus B plus C. Add these two, A plus B plus C. Last one, add these two, A plus B plus C. So second column is second column plus first column. 1, 1, 1. Now you can take that A plus B plus C outside. So you will get 1, 1, 1. Second column 1, 1, 1. Third column 1, 1, 1. 2 columns are identical. So the value becomes 0. So 1 by 2 into, you can take that A plus B plus C outside. You are getting A, B, C. 1, 1, 1, again 1, 1, 1. So equal to 0, write the reason. C2 is equal to C3. Therefore, the given points are collinear. Collinear means they lie in a same line. Now let's move on to the next question. Please listen. If K2, an unknown is there, so find the value of K, that's the question, right? K2, 2, 4, 3, 2 are vertices of a triangle of area 4 square units. So area of triangle, they given us 4 square units. Area of the triangle, you know the formula, half into x1, y1, x2, y2, x3, y3, 1, 1, 1, right? So equal to 4 they given, area 4 they given. So please listen here, you have to be very, very careful, students. Many students make mistake here. Area is 4. In the calculation, you would have got either plus 4 or you would have got minus 4. Even if you get minus 4 in the calculation, we are going right, area of the triangle is equal to 4 only, right? So in the calculation, you would have got plus 4 or minus 4. Then when you write the final answer, you take plus 4 only, right? In the calculation, you would have got either plus 4 or minus 4. Now take 2 you take there, so it becomes 4 2s are 8, plus or minus 8. At the same time, substitute the values x1 and k2, 2 4, 3 2. Last column 1 1 1. Now please listen. So expand it k into, leave the row and column, 4 and 1, 4 minus 2. Second number minus 2 into, leave the row and column, 2 into 1, 2 minus 3. Third one plus 1 into, leave that row and column, 2 2s are 4 minus 12 equal to plus or minus 8. If you're not taking plus or minus, you may miss one answer. Okay. So 4 minus 2, it is 2, so 2k. 2 minus 3, it is minus 1. Minus 1 into minus 2, it is plus 2. Here minus 8, right? Equal to plus or minus 8. So 2k minus 6 equal to plus or minus 8. Now we split into 2. 2k minus 6 equal to plus 8 or 2k minus 6 equal to minus 8. So 2k equal to 8 plus 6, 14. K equal to 14 by 2, 7. Or 2k equal to minus 8 plus 6, minus 2. K equal to minus 2 by 2, k equal to minus 1. So the two values for k, minus 1 comma 7. If you're not writing plus or minus, you will get only one answer. So be very careful in this sum. Okay. Now let's move on to the next question. Find the value of the product. Please listen, students, before doing this sum. Just I'm going to explain one result. Already you have studied. Base changing rule. Log a to the base b into log b to the base c can be simplified. Here it is multiplication, and cross you see these two are same. Either these two are same or these two must be same. Then you can simplify. Since these two are same, that one you leave it and your answer is log a to the base c. Suppose even log a to the base b into log c to the base a. Here also you can simplify. These two are equal, right? So it is log c to the base b. Sometimes both may be equal. Please listen, both the diagonals. So log a to the base b into log b to the base a. Please listen, here these two are equal. You can leave it. So your answer is log a to the base a. The answer is what? 1, right? That is one method. So these two are equal, these two are equal. Then straight away write your answer as what? 1. The reason I can give different proof for this, log a to the base b. Log b to the base a can be written as 1 by interchange, log a to the base b. Then both are same, no? So that is why the answer is what? 1. Logarithm already studied. Okay, now please listen. We have to find the value of this. So we are going to row by column multiplication. Row by column. Like matrix, I'm going to multiply. First row, first column. So what do you get? Log 64 to the base 3 into log 3 to the base 2 plus log 3 to the base 4 into log 4 to the base 3. First row, first column, we finished. Now first row, second column, first row, second column. So log 64 to the base 3 into log 3 to the base 2 plus first row, second column, right? Log 64 to the base 3 into log 3 to the base 8. Now you plus log 3 to the base 4 into log 4 to the base 3. Now come to the second row. Second row, first column. Log 8 to the base 3 into log 4 to the base 3 plus log 9 to the base 4 into log 4 to the base 3. Please listen again. Second row, first column. So here won't change. Log 8 to the base 3, second row, first column. Log 8 to the base 3 into log 3 to the base 2 plus log 9 to the base 4 into log 4 to the base 3. Now the last one. Second row, second column. Log 8 to the base 3 into log 3 to the base 8 plus log 9 to the base 4 into log 4 to the base 3. Now please listen. The properties and all you have to remember. See these 2, 3, 3. Leave it. Log 64 to the base 2 plus here these 3, 3, 3. The other also 4, 4. So your answer is what? 1 for the next one. Now come here 3, 3 equal, no? So leave it log 64 to the base 8. Log 64 to the base 8 plus next one here 4, 4, here 3, 3, right? Both are same, so the answer is 1. Come here 3, 3. Leave it. So log 8 to the base 2. Plus log 9 to the base 3. Hope you understood this. 4, 4 equal log 9 to the base 3. Here 3, 3. So log, and here 8, 8. Both are same, no? So you write what? 1. 4, 4. So leave it. So log 9 to the base 3. Now please listen here. Log a raised to m. You can write it as m log a, right? You can write it as m log a, and log a to the base a is equal to 1. So with the help of these two, log 64 can be written as base is 2. 64 can be written in many ways, right? 8 square, 4 cube, 2 raised to 6. Here we are taking 2 raised to 6. Why? You know, because the base is what? 2. Log base is 8. So 64, 8 square you write. Plus 1. Then the second one, log base 2 is there. So 8 you write 2 cube. Plus log base is 3. So 9 can be written as 3 square. 1 plus log base is 3. So 9 you write 3 square. Now apply power rule. When you apply power rule, 6 come front. 6 log 2 to the base 2 is 1. So 6 into 1 it is 6. So 6 plus 1. Next one 2 comes front. Log 8 to the base 8 is 1. 2 into 1 2 plus 1. Next one 3 comes front. 3 into 1 plus 2 comes front. 3 plus 2. 1 plus 3 square. The 2 comes front. 2 into 1. Log 3 to the base 3 is 1. So 6 plus 1 7. 3 5 3, right? Now just to simplify this, expand it. 7 3s are 21, minus 5 3s are 15. So your final answer is what? 6. Very simple thing. Only thing, the log properties you have to be thorough, then you can do it very easily. Okay. Now just I'm going to help you another 1 or 2 questions. Find the value of b if, find the value of b, small b. There is an unknown. Yes, we have to find b value. If this matrix is singular, you check, is it a square matrix? Yes, it is a square matrix. Singular means the corresponding determinant must be 0. So since b is singular, you can say determinant b equal to 0. With the matrix you can't do anything. Convert it as a determinant b minus 1, 2, 3, 3, 1, 2, 1, minus 2, 4 equal to 0. Now just expand and find b value. So expand it, b minus 1 into, leave the row and column, 1 into 4, 4 minus 4 plus 4. Take the second number, change the sign, minus 2 into, leave the row and column, 3 4s are 12, minus 2 into 1, 2, plus 3 into, leave the row and column, minus 6, minus 1 equal to 0. So 4 plus 4 is 8. So 8 into b minus 1, minus 2 into 10, plus 3 into minus 7 equal to 0. So 8b minus 8 minus 20 minus 21 is equal to 0. You are getting 8b minus 49 equal to 0, right? So 8b is equal to 49. B is equal to 49 by 8. If you get 48, you would have cancelled. So we may have a doubt if we get a number like this, right? Whether it's correct or not. Yes, it is correct only. If you want, you can check again. 49 by 8. You can leave it. Okay, just I'm going to help you one more question. If cos 2 theta is 0, determine the value of this. Please listen, student. This one can be done in different ways. I'm going to teach in a very simple way, the easiest way. Okay. See what is given here. Cos 2 theta is equal to 0. Cos 2 theta, cos 0 is 1. Cos which angle is 0? Cos 90 is 0, right? So this angle must be 90. So you can say 2 theta is equal to 90, pi by 2. So theta is equal to 45, pi by 4. Sometimes what we do, we take RHS square, you write 2 times, simplify. But very simple. Theta value pi by 4. Question is determine, that's all. So we want to find the value of, so we have to find the value of what? Determinant. Yes, this is what we want to find, right? So what I'm going to do, just wherever theta comes, you put pi by 4. So what you get? 0, cos pi by 4, sin pi by 4, cos pi by 4, sin pi by 4, 0, sin pi by 4, 0, cos pi by 4. The whole square is there, right? Now you substitute the values. 0, cos 45, 1 by root 2, sin 45 also 1 by root 2, right? 1 by root 2, 1 by root 2, 0, 1 by root 2, 0, 1 by root 2, right? The whole square. If you want, you can take 1 by root 2 and all outside or straight away you simplify. The whole square is there. First 0 into anything, 0 only. So take the second number minus 1 by root 2 into. Leave that row, leave that column. So simplify. 1 by root 2 into 1 by root 2. 1 by root 2 into 1 by root 2 means 1 by 2, right? Minus 0. 1 by 2 minus 0. 1 by root 2 into 1 by root 2 is 1 into 1. 1 root into root is 2. So 1 by 2 minus 0. Third number plus 1 by root 2 into. Leave that row, that column. 0 minus, you multiply these two. When you multiply these two, what do you get? 1 into 1, 1 by 2, right? So 0 minus 2, right? 0 minus 2, minus 1 by 2. The whole square, don't forget to put that. Now this is minus 1 by 2 root 2. Here also plus into minus is minus 1 by 2 root 2. So 2 root 2, you take LCM. Minus 1, it is minus 2. But the whole square is there. Okay, should not forget that. So you are getting minus 1 by root 2 the whole square. Minus when you square it become plus. 1 square is 1, root 2 square is 2. So this is your answer. Okay, hope you understood this. So learn the concepts thoroughly. Then work out these questions. Based on that, try to work out the other questions. Hope you can do that sums. We'll continue the next video.